Today I'm going to be talking about linear equations, including things like graphing them using x and y intercepts, and also determining whether a point is on a graph or not. So when you have an equation, let's say we have y equals 5x plus 3. What you want to do to begin, you want to make a t-chart. And a t-chart is basically it's a chart that looks like a T. It has a column for an X and it has a column for a Y. And when you're making your t-chart, you basically get to pick your X points. They could be any number, positive, negative, they could be decimals, fractions, it doesn't matter. The only thing is you have to pick at least 2. And the more X values that you pick, the more accurate your line is going to be. So the X and the Y values are the coordinates or the ordered pairs that you're going to graph to make a line. So when you have this ordered pair or this t-chart, you get to pick your X values. It does not matter which X values you choose. They could be different from the ones that I use. They could be different from the ones your teacher uses, some of your classmates use. It doesn't matter. But for this problem, I am going to use -2, -1, 0, 1, and 2. Like I said, you only have to use two X values, but the more accurate your graph is going to be. And so, like I said, our equation is y equals 5x plus 3. And what you're going to do to find your y values is you're going to plug your x into the x position in the equation for each of these. So for the first one, you would do 5, and that would be a times -2 plus 3. And so you're going to solve that, and that answer is going to be -7. And you're going to do this for each x value that you have. So 5 times -1 plus 3. Let me go ahead and write these out to the side so we can know. So that's going to be -2. And so that's going to be the corresponding y value for that x. And now for the 0. That's 3. So then you go ahead and plug that into your chart, your t-graph, and you continue with that. And these are going to be the points that we're going to use to plot this equation onto a graph, to make a line graph. So I already went ahead and drew the graph. When you draw your graph, you can count by ones. If there's very big numbers, you can count by 5s, you can count by 2s, and if your y values are even larger than that, or your x values even, if they're larger than that, you can count by hundreds, thousands, even millions. You just have to indicate what you're counting by. And so as you can see on this graph, I'm counting by ones. For every 5 tick marks that I put onto my graph, I make it a little bit longer. And I also label it. You don't have to make them longer every 5 if you don't want to. I just find it helps with the counting. Even if I have already labeled it, it still makes it easier. So there's that. I've labeled my axes. That's my x-axis, that's my y-axis. And so what we're going to go ahead and do is plot our points onto our graph. And so -2, -2, -7. We're going to go ahead and plot that. We're going to count out 1, 2. This is negative. And then we're going to count out to -7. We're going to count down to -7. So -2, -1, -2, -3, -4, -5, -6, -7. And that's where our first point is going to be. And the next one is -1, -2. Let me show that right there. -1, -2. So we're going to go -1, and we're going to count down to -2. -1, -2. And our next point is 0, 3. So here's our 0, and we're going to that one's positive. So we're going to count up 3. 1, 2, 3. And our next point is 1, 8. And both of these are positive. So this way we're going to go 1. And like I said, since we labeled this one 5, we already know that's 5. So 6, 7, 8. Our next point is 2 and 13. So there's 1, 2, 10, 11, 12, 13. And we're going to go ahead and do that. And since we have those points plotted, we can grab our ruler and connect our dots. We can go ahead and draw our line. And so since linear equations are infinite, we don't stop just at our last 2 points. That would just be a line segment. So we would keep this going, and we don't, since our page stops, we just symbolize that it keeps going by using arrows in both directions. And that's how you plot a line graph, a linear equation. Okay, so now I'm going to show you how to graph a linear equation using your x and your y intercepts. Intercepts are when the equation crosses the graph at the x and y axes. The y-intercept is when x is equal to 0, and the x-intercept is when y is equal to 0. We're going to use the equation 3x minus y is equal to 6. Now this equation isn't in standard linear equation form. And normally when you see an equation like this, what you want to do is you want to solve for y, or you want to rearrange it so that the y is on one-sided equal signs by itself. And when you're solving for your x and your y intercepts, you don't have to do that. And here's how. You would set up your t-graph, your t-chart, like normal. But instead of just choosing any x's, you're going to choose 0 for your first x. That would be the y-intercept. And since we're looking for the x-intercept, we're going to establish our y for our second point already, and that will also be 0. And what you want to do is you want to solve for y, and you want to solve for x. So we're going to start by solving for y. So we would plug our x into our equation, and we would go ahead and work this out. So 3 times 0 is 0. So that leaves you with negative y is equal to 6. And so since we know that a negative in front of an x or a y is an assumed negative 1. So what you want to do is divide by negative 1 on both sides, and that leaves you with y is equal to negative 6. So in your t-chart, you would go ahead and plug in negative 6 for that y. And you would do the same thing for when you're solving for the x on the other side. You would take your equation and you would plug in your y value. And you would solve for x. Or when you subtract 0 from something, it's the same thing. So it will leave you 3x is equal to 6. And what you would do is divide by 3 on both sides. And so that will leave you with x is equal to 2. And you would go ahead and plug that into your t-chart. Like I stated before, you only need 2 points to graph a line. And what you do is you would draw your graph just like normal. And since it's not very large, we don't have to extend it very far up. And so we have our points. When x is 0, you're at negative 6. So that's negative 5, negative 6. And at 2, when x is 2, you're at 0. And so those are your 2 points. You would take your ruler and you would draw your line. And that's how you graph with your x and your y intercepts. So sometimes you're given an equation and an ordered pair, and you're asked to determine if that ordered pair is part of the line. And oftentimes with these types of problems, they'll give you a graph with the equation that's already been graphed. And the ordered pair that they give you may look like it's on part of the line, but it isn't always. So we're going to go ahead and try to determine whether this point, this ordered pair, negative 2.5, comma 0.7, is part of this equation, the line of this equation. And so what you're going to start off by doing is you're going to plug in your ordered pair for your x and your y values. And you're going to set it up. Negative 4 is equal to negative 2.5 minus 2 times 0.7. And you're going to go ahead and solve this part and see if it's equal to this side. And if it is, then your ordered pair is part of that line. And if it's not, then it's not part of that line. We're going to go ahead and solve for this. So 2 times 0.7 is 1.4. So we're going to go ahead and work this down. Negative 2.5 minus 1.4. So negative 2.5 minus 1.4 is negative 3.9. And that is the answer with these coordinates into the equation. And so now you have to find out, is negative 4 equal to what this equaled, negative 3.9? No, it's not. And as you can see, they're close. So if you're given a graph with a line on it for this equation, it would be very easy to confuse negative 3.9 for negative 4. But you have to be sure and plug in the ordered pair into the equation to be positive. So no, this ordered pair is not part of that line. So an easy way to find out what the line of an equation looks like, and also the x and y values for that equation, is to use your calculator. And I'm going to show you how to do that now. So what you want to do is you want to go to the y equals. It'll look like this. In the y equals, you will type in your equation, and we're going to use this equation. So we'll type in 7 minus 5x. And that's the equation that you're given. What you want to do if you want to find your x and y values is you're going to hit second graph. And that will show you your x and y values. And so to find out what the line of this graph looks like, you would hit graph. And it'll calculate it for you. That shows what the line for this equation looks like.